Hi, Serena. Hmm.
Hello.
We had a team meeting, so we are a little bit late. I'm sorry about being a little bit late, everyone. But thank you for coming. So we start having these rooms on Sundays. We thought to um, we have a lot of guest speakers throughout the week. It can get like, once the weeks go on and on, it can be kind of difficult to remember what we all discussed and what the rooms were about. But also, if you didn't have time to attend all the rooms, or and you don't want to go through hours of replays, which I can totally understand, we decided to make these weekly recap rooms where we shortly summarize what our guest speakers talked about here. And then the idea is to make out of this room then a newsletter audio version, a shorter one, where it summarizes again what went on this week in the Science Society. And then we will post it. We have now a podcast account, Spotify, and we have a YouTube account, and then we'll post these recap rooms additionally to the regular room replays to all these accounts. So for example, I really like Blink and stuff like that. I used it for a while a lot. Not that I still use it, but I think it's also a very useful way of just getting a summarized version of things. I think it has definitely. Thank you, Blake. I appreciate that in the chat. So, okay. So let's start with the paper that is pinned to the room. We had the senior author, Kik-Yang Yi, here talking about this research. Also, I wanted to give you again a short summary about the guest speaker. He is a really distinguished a professor that received a lot of awards, including here in the US. He was a professor at Emory University for many years, for over 10 years, I think 15 years or so. And now he's the department chair of Shenzhen Institute of Advanced Technology in China. But he still collaborates a lot with Emory University. So this paper is one of these collaborations. And they are actually moving on to having early stage clinical, preclinical, and clinical trials. And this paper is about that the hormone FSH, if you block this hormone, it improves cognition in mice with Alzheimer's disease. And why they came about to do this project and to try blocking this hormone is the prevalence of Alzheimer's in women is threefold higher than in men. And it is known that during and after menopause, that this hormone is higher in women. And it was known to, with the increase of this hormone, that a specific, like the right away, some cognition decline is observed in women, and quite, like, it's quite prevalent. So yeah, they started studying this hormone more systematically, and they found that the blockage can improve cognition in mice with Alzheimer's. So yeah, so they are designing a human study, and it's really exciting, and I think it will be really helpful for the future. If you have any short comments on this, in the meantime, I'll start pinning the next one.
Yeah, I just point out that it was noted that there's multiple routes to the cognitive decline and the dementia and with Alzheimer's. And in men, it was more metabolic and hypertension. But certainly the 3-to-1 observed in women is in part due to the FSH pathway.
Yes, and the interesting thing is that they are studying if, because on one hand, in men, there's less prevalence in Alzheimer's, but more a higher prevalence of Parkinson. And they see it that it's basically the same underlying disease, just in different cell types, that it just affects different cell types in men and women, basically. And they are now looking if FSH, that is still present in men, if it contributes to the Parkinson illness. The reasoning why I think it still makes sense, although FSH is lower in men, is that estrogen throughout life in women until menopause acts as a protective agent, basically. And then once the estrogen drops, FSH can do its harm, basically. And that this protection doesn't really occur throughout life that much in a man, and we know that the cell death uh, starts way earlier than before we see any symptoms of Parkinson. We only start seeing symptoms of Parkinson's disease once already over 50% of the neurons are dead, because the brain does a really good job at compensating for a loss. So, so that's why I still think it makes sense to study it.
And the discussion led to the clear follow-on, what about hormone replacement therapy? And essentially the jury wasn't, it wasn't conclusive that it would help, but there's still some suggestion there. So further investigation.
Just quickly, FSH stands for follicle stimulating hormone. Is that right?
Yes.
Thank you.
Okay, if somebody in the audience has comments or questions about what we discussed, if we go through it too fast, please comment in the chat or just raise your hand and participate. Yeah. Then the next paper that was discussed was by our guest speaker, Dr. Tita Sengupta. She was, when she did the research, a graduate student at Yale University. She's originally from India. She did her education at the Institute of Science and Education Research, Kolkata, India. And she is now a postdoc researcher at Princeton University. And so this paper is a neurodevelopmental paper, and it's really extensive work. It basically summarizes her whole PhD, which is an amazing PhD project. It's so yeah, you want to chime in? I'm sorry, I don't see the
Oh, I
screen
was
while I
I
type.
was just cheering it on. Yeah, it was a real tour de force, both experimentally and in terms of the findings and implications.
Yeah, it's amazing. So the first thing they did was develop a whole new microscope system to to in order to observe these mechanisms that happen during development. So that was the first thing. So so uh, so they developed first this really cool tool that enabled them to observe throughout time in a living tissue the and the living organism was C. elegans. It's like a very broadly used animal model for basic cell neural mechanisms because we know pretty much almost everything about. We know every single neuron. We know the genome. We know how to change it. So we can do basic behavioral stuff like motor neuron stuff. We can even do some threat response. So it's a really cool model, and a lot of big scientists use this model to give us a lot of really important insight into how neurons work and so on and so forth. So they developed this system where you can continuously observe um, the development of the neurons without damaging the system. Because the problem is, if you keep making detailed images of any living tissue, you usually damage it quite extensively, and you cannot keep doing it. To get, for example, really good two photon images of like little synapses and dendritic arbors and calcium response, you get photo damage pretty quick, like after a minute or so. So they developed a system where you can keep performing these images at a quite um, detail throughout the development, which is really very cool. And they, also the data analysis platform they developed is very impressive. And you can look it all up, how it works, and it's the platform they developed. Everyone can just go ahead and use it. So that's the first thing they did. And then on top of it, they figured out how these neurons find their place where they're supposed to be functioning in the network, and what the mechanisms are. And then on top of that, they even figured out how to manipulate that. And so it's really extensive work. And yeah, it gives us a really good insight into those mechanisms. And this is important for so many things in the future, especially regenerative medicine. Let's say we start making new tissue for people and innovate the tissue, and also neurodevelopmental disorders. Like, this will be helpful on so many fronts. So yeah, this was really great work. But please go ahead and comment if you would like.
Yeah, I thought that the um, insights and of what was observed was profound in the sense that there's pioneering neurons, initially pioneering glial cells, but then um, early neurons that sort of lay out the territory and express, I believe it was SYG1 and 2 as a ligand receptor pair. But then follow-on neurons can follow a gradient, and the zipper mechanism that she describes, I believe, is successively laying down desmosomes, which is these adhesion proteins across neurons, and presumably that they can lay new ones down and pick old ones up. But in essence, it was a wonderful insight into how neurons can lay down an initial structure and have following neurons fall into or basically extend the structure through genetic control of these expression proteins. So fascinating implications.
Yeah, and then also like mechanic pull and push is also really important. So yeah, it's was really impressive work.
Because I missed that session, I was curious how this technique was different. I understand in terms of damage, but like in terms of the mechanics, how about, were there any details on that?
I actually missed the details of the physics behind the imaging method too, and I'll have to go back and look at it deeper. But it really seems significant in the sense that it avoids the damage that contemporary methods have to deal with.
So she didn't go. She went more into detail in the in the biology part.
The results rather than the
Yeah,
technology.
how they did the SNP mapping, and so it is in the core. It is confocal imaging, but they used like a different spinning disk, and they used, of course, the fluorescent tagged fusion proteins.
We lost your audio, Katerina.
I think her Wi-Fi might have cut out because the mic just went unmuted, or muted rather. Oh, there we go. She's back. I think. Katerina, not sure if you can hear me or not, but try coming in and out of the room again. That might help.
Uh, before Katrina can uh, continue, I'll just quickly, because this is really late for me. To it's kind of overstretched in order to join this room and after our meeting. So I'll just quickly do my part, fill in for the Xantropy talk that I really liked, and it's Xantropy is Z plus entropy. I believe the Dr. Z.K. Liu from Professor Liu from Penn State used that Z from it's a German word for sum. So essentially, it's a sum of entropy and entropy components. I mean, and it's very cute. Where I think there's probably some movie or something related to that as well. The what's interesting of this work is actually it enables the uh, how should I say it is it's a mathematical provable theorem. Katrina, I'll just quickly finish with the Xentropy part, and I'll give the map back to you soon. The I think the in terms of applications, we don't always be able to access the finest the the true the true entropy. So what we do is we do some type of a coarse graining, and say we pick a level uh, from the bottom, two layers up from the bottom. We can say N1 is the finest level, and N2 is one level above, is coarser. So at that level, we can define some using conditional probability define entropy. You can think of a 4 by 4 like grid at the very bottom. Now we are one level above is like 2 by 2. So now we do calculation. We define entropy at the 2 by 2 level. Then that layer. Then for each square we have a SK. That's essentially we basically sum up the finer level and use that to sum up as the sum of the finer level, and then plug into the which if you were in the room, then another uh, uh, physicist, Hansen, were able to point it out. It's actually provable. It's very exciting results. That's actually Professor Liu acknowledged that it's also the recent work is their paper 2019, and yeah. So basically this work, this formula will allow. I mean, I mean the concept of entropy they propose allow a more flexible application to systems where you know uh, measurement and information is not readily available from the most refined level. Yeah, I think that's very interesting. That's what I got out of the. Please add more to complete the picture. Yeah, I'm going to sign off after this. Thank you.
Yeah, that was very fascinating work. It had both, it offered a theoretical treatment in accounting, but in the applied section, it was demonstrated that it was instrumental in tracking particular behavior in materials at phase transitions in that weren't really accessible in other ways. So it had practical applications for computational material science as well. So it was excellent work.
And that's the value of getting a whole bunch of people who are really into science together. We get to cross-pollinate the ideas, and maybe you take a technique from here. Oh, I hadn't thought of that. I love it.
So Katerina, are you back?
Yeah, can you guys hear me now? I'm
Yes.
so sorry. I was talking and talking about the methods they were using, and I didn't hear that, people couldn't hear me. And since I'm on the paper, then I don't see the screen. So I really apologize. Somehow was a glitch on my side.
No worries, no worries.
So yeah, thank you, Frank, for describing it. And I just wanted to also tell you a little bit about Dr. Liu. He's a really accomplished professor at Pennsylvania State University. He founded the NSF Center for Computational Materials Designs and was the director there for many years. And he coined the term materials genome. He published like over 540 paper. What was this paper? It's
565 was he?
565 paper. And he is published and reviewing it, and he will present it to us once it's out. So yeah, he is really nice, and he went really like I think he enjoyed the room a lot, and yeah, he was really a fun speaker to have. So yeah, he's so impressive. He made like on the night he asked for the audio file, and during like at 7 a.m. in the morning he already sent me a YouTube video he made out of our meeting because he had the Zoom screen on at the same time. So there is already a YouTube video with him talking with the video and the slides at the same time. So yeah, he is a very efficient, very interesting and knowledgeable person.
Yeah, I think I agree. Yeah, I agree. And Professor Leo is the type of a scholar that the best for Clubhouse for science society.
Yeah, it was a lot of fun. Like even if you didn't understand the science that well, I think it was a lot of fun. So I saw in the chat that yeah, Jonathan, oh, but he's not here anymore. Anyways, I wanted to tell him once he goes through like a week or two of our rooms, I think you will get like the basic knowledge to understand any science topic, at least the basic idea of it. If you go through our training, basically, I think.
We really do try to balance getting deep into the technical aspects of the paper, but also making that accessible to a wider audience. And so, yeah.
Yeah, I think the speakers do a good job of giving first like the broad idea why and like the broad understanding of it, and then with our questions we get quite technical, but I think one will get the understanding of the basics. So then we had the senior scientist and the PhD student, both very accomplished scientists already. The PhD student, he was already on over 12 publications, and he has its own YouTube channel, and he's also here on Clubhouse. And then the professor, so that is Manish Girn, if you look for him on Clubhouse. They are at the McGill University. And then Danilo Bzdok, he's a medical doctor and he has 2 PhDs. So one from so his medical doctor degree has from the University of Lausanne in Switzerland, and then he did 1 PhD at Harvard Medical School in brain imaging, neuroscience, and 1 PhD in computer science and machine learning statistics at the INRIA Saclay Neurospin University of France. So I feel so dumb and lazy when I read that. Anyways, they did a really impressive, very large scale study where they looked at text data from self-posted text data of people that were taking different hallucinogenic compounds. They also had brain imaging data from those data sets that are publicly available and went through. So this is the largest ever systematic study in this field that was ever done with computational analysis, and I really like that study a lot because it brings kind of a more very systematic way of thinking and going through the data, and they really saw interesting patterns in the language data and in the brain imaging data, and they went through a really large data set of a lot of different hallucinogens. So yeah, I really recommend reading the study if you're interested in that field. And we asked how diverse the population is, and there's for sure in the future we have to do a better job at having a more diverse population in these studies, but it's a start, and I think it's a huge start, and it brings kind of a systematic scientific approach into the field that was never done before. So I really appreciated their study and their sharing of the study here. If you have any comments, please go ahead.
I took notes. I take notes on all of our sessions just because, I don't know, I do that. But there were 7,000 reports that they pulled from. There were 27 different classes of substances utilizing 40 biopathways, and there were 14,000 words. And they were able to roughly break it down into visuals versus reality were sort of the two ideas that came up the most in the self-attestation. So I like that part.
Yeah, it was interesting how they had, a factor space down to the receptor types, and the speakers were really leaning into, well, give us, so it would associate, or it would point out word phrases commonly used in these self-reports and these texts, and mapped onto these receptor subtypes. And so, give us an example of phrases for. But then one of the examples was that for the NMDA receptor words, more like universe and oh, I can't remember some.
Inhale and entity.
Yeah, entity. But just as the extremes. But it gave a component dimension to those receptor subtypes. So it was interesting. It gives you a factor space to sort of separate the different word and phrase usages and how that might map onto different receptor subtypes. So fascinating stuff.
I liked how it was both qualitative and quantitative observations. They integrated both of them really well.
Yeah, it's always fascinating to me how much language actually reflects what is going on in our state of mind. It's really, I think it's really interesting, and I like that approach because I use that approach for different studies that I did for mental health related. So of course I'm biased, but that's why it was extra impressive to me to to see those patterns and how much it can tell us what is actually going on, which is cool because it's so much cheaper in the long run once we establish that with brain imaging and so on. And I did this in a depression study where they did also brain imaging and used different drugs, antidepressant drugs with naive patients. um, Once we really established how that language is a quite reliable reflection of what's actually happening in the brain, it's so much cheaper and it's so much like it's scalable. It's really impossible to scan all the brains of people that have mental health disorders because those devices are really expensive and not broadly available, especially around the world. So if we can continuously establish that language screening, the better, because that we can actually turn into a scalable analysis tool. So, which we had the room a while ago with Dr. Fields that is actually working on a more scalable version of brain imaging, where he developed this brain scanning headset that usually what does an MRI and all these devices cost, like $1 million, $500,000.
You can get the cheap ones on eBay. They're like 30,000, but they're the old ones.
Yeah, really old. So, and they're huge and stuff, right? You cannot. People have to lay down quite still, and so it's really not an ideal situation to do brain imaging, and certainly not a scalable one. So Dr. Field, the guest speaker we had here, I think a month ago or so, in February, he is developing or developed a device that it's a headset. You can the good thing is you can move with it, and it's way cheaper. What I think the cost was right now for a new one, 30,000, and this is the beginning cost of the technology. Right when you have a higher demand and systemize the production, it can get even more cheaper. So that was another amazing guest speaker we had here. But it wasn't this week. It was a while ago. So yeah, we should have started these way earlier. These recap rooms. Another very cool research team we had here. Again, we had the two scientists, that the senior scientist, Dr. Jawed, and his colleague, Dr. Charbel Habshi. They were here presenting how ballooning and spiders using multiple silk threads work. That was a really cool mechanical, more engineering type of study, using machine learning. They developed these models of how ballooning and spiders work. So for people that don't know, spiders can actually kind of fly. So they use this very long silk threads, and then they can fly for miles and miles.
Hundreds of miles was what they said. I was like, wow, really?
So that's how they spread around the world, I guess. And people didn't really know how this works. So, and they did a really cool model that makes way more sense than what was thought before. And their hypothesis is that this ballooning is caused by the presence of a negative electric charge of the spider silk threads and the positive electric potential in the field in the Earth's atmosphere. So yeah, they presented this model. Let me try to find the YouTube video they created where you can check the model out. I'll pin that. And in the meantime, maybe if anyone wants to add something, comment, please do.
What was cool about the mechanism is I was curious how does the spider separate the charges to, in essence, have a net negative charge on the silk, and in essence, it came back to rapidly ejecting the the spider silk. So in essence, a mechanical based charge separation to give a net negative on the silk, and that allowed this spider silk to carry this charge. And of course, there's clear weight limitations in how this effect could work, but it was fascinating.
Yeah, I agree. It's a really cool study. And yeah, they will be for sure also back again with updates and with different projects. And yeah, I don't know, but yeah, they were a really good team at presenting this. Dennis, you wanted to say something?
My favorite part of that talk was how the spiders used the structures on the back of their legs to things, you know, integrating their anatomy played with earth physics. That was really cool.
Okay, let me get the last link. On Friday, we had another guest speaker that that uses a different approach. It's again computational. That he so oh yeah, there's a link. So Dr. Sean Chen, he is in the UK at Cambridge University, and what he does, he goes through data, hospital records, and analyzes them and visualizes them for clinicians so they can evaluate the effect of different interventions on patients and also explore the potential risk of interventions and factors of interventions, that like how useful they are, what's the status, and what the outcome is. So basically uh, provide a more data-driven approach and more systematic approach to evaluate different interventions that are being utilized in the hospital. So this was again a pretty big study, where in this case his expertise are also in COVID-19 data sets, dementia, schizophrenia, and so on. So he will hopefully, he agreed to also come back and tell us a little bit more about his COVID-related mental health studies he did. But yeah, this was a pretty big study where he looked at people that had dementia and compared. So they were all 50 years and over, and in one group, the patients had been prescribed lithium, and in the other group of patients, they didn't. And this in this cohort, there were 29,618 patients were included, and then out of those, 548 were exposed to lithium, and the mean age was actually 73.9 years old, and it was pretty divided by male and female, 40% male, 33% female. And he also looked at if they were married or not, and so on. So 71% were still married. And he screened all that data sets, and the conclusion was that there seems to be an association between lithium use and the decreased risk of developing dementia, which may be supportive of the idea that using lithium may be a disease-modifying treatment for dementia, and it could be promising to continue this. And my suggestion was to like, and also the future would be to now look into more mechanistics, why lithium seems to be helpful. And I think it's a pretty interesting study, and I like these type of studies where you go through the data set you have already aggregated and gain insights from it, because we have a lot of data. We just don't have enough people like Dr. Chen that systematically look through them and look at the bigger picture. So I like that.
What really stuck in my mind, and you got to kind of smile. They looked at cases where the water supply had a higher concentration of lithium there for whatever reason, and they were able to have it observe in a statistically significant effect, even with it being in the water supply. And of course, you got to think there's for some entrepreneur, that I don't know what the therapeutic levels are versus, I didn't look into that. But the whole notion of putting it in the water, or like we do with fluoride, or a particular bottled water product, is just kind of amusing. It's the association with apparent protective effects seems to be there. So, what about that?
Yeah, there are a lot of if it's actual spring waters that went through deep sediment, it's naturally in there. It's just if you don't use like a deep sediment water, basically groundwater, then it's not in there. Or if you like use just filtered water where you filter everything out, it's not in there anymore. So yeah, it's interesting. It's a public health. It's a big public health study. Basically, I like those.
Just make sure there's no other harmful substances in your groundwater source, or there might be beneficials, and then that'll be outweighed by the unbeneficials.
Oh yeah, please don't go to a puddle and take that water. There may be amoeba in the your brain and stuff. Like, don't do that. But if you may, if it's I yeah, in Europe there's a lot of clinics and stuff that use these natural deep spring waters, but it's pretty regulated. Like with the quality is constantly checked. So yeah, don't just go ahead and use your own groundwater in the backyard that is maybe just a meter or 2 meters deep. But there's definitely an upside to leave sediments and stuff in there that were supposed to be in the water. At least that they're huge data sets like in Europe from these type of. It's like a very traditional approach. Uh, they have this healing clinics for chronic ill patients, and you get paid like it. At least in Germany, it gets the public health pays for it if you like have chronic rheumatism or mental health issues or stuff. It's like a
Wait, they pay
hospital
for
plan.
it?
Yeah.
Wow. That's
Yeah.
like inconceivable in the US currently.
Yeah, like my mom, she had with different chronic, like we have different chronic illnesses in our family. So yeah, they pay like 2 weeks every 2 years or so. So you go to these clinics, they have you completely checked out. There's a nutritionist, mental health specialist, people that make you an exercise plan, and then you have these natural spring waters. It's actually kind of like FDA approved water, so they are heavily regulated, and then you walk through them, you bathe in them, you drink every day from them, and you're supposed to walk in nature. It's like in nice nature spots, like either by the sea if you have lung issues, like more respiratory issues, and it's in the Alps or in other nature spots. It depends on what you have. If you have allergies, being high up above 2,000 meters is good for you, because there are less allergens because those microbes
The air
don't.
quality tends to be better, yeah.
Yeah, so there are different spots depending on what illness you have that they send you. If you're a single mom, I think you have the right to go every 2 years with your children to de-stress. Then you get taught like parenting approaches, like all of this type of stuff. It's really good, and I think it's really helpful.
That sounds so cool. I had no idea.
Well, yeah, it would be straightforward to produce a formulation with lithium supplements, but you got to be careful with that. whenever the business gets ahead of the science. But it was some interesting suggestion that there's apparently an observable effect for lithium as a protective approach for dementia.
Yeah, I think that was mostly our week. We had, more roundtable, couple of rooms yesterday and on Friday that we discussed our positive and negative recent publications where AI can be leveraged in a very positive way, like finding new drugs, new antibodies to treat different disorders, but also very negative ones, scary ones, where you can develop fairly easily bio or weapons out of compounds. So we discussed that and how to regulate it and what our responsibilities are. Yeah, so I think it was a really interesting week. We have a really interesting week ahead. So follow the club if you like these rooms. So we have on Monday really just an introduction meeting for one of our guest speakers. We'll introduce them to the club and to Clubhouse. Dr. Mackenzie, he will be speaking on Wednesday. He looks at chiral molecular interactions and different types. It's important for basic chemistry, for basic material development, and now he looked at those interactions in living cells. It's really cool. It gives us insight into very basic or fundamentals of molecular biology. So it's a really important study, and we'll have that room on Wednesday since he's in Europe. It's at 1 p.m. EST. And then a room I'm really looking forward to is on Tuesday at 9 p.m. EST. We have the senior scientist, Dr. Rushan from Google, who developed the time crystals with quantum computing. And we had kind of a little bit of a roundtable discussion on Friday here about the time crystals. And and he gladly said yes to come and answer more questions we had. So yeah, he will be coming on Tuesday. And then we'll have Dr. Fletcher. He is also a scientist, a neuroscientist, and he developed a more systematic method for training creativity, so everyone can be more creative. It sounds like, it's just fun. Being creative is just a fun artsy thing to do. I think being creative is the most important thing to train for the future, because we need more innovations at a faster pace. We have not just exponential growth and resources need, super exponential growth and resources need with a limited time. And we don't have a super exponential growth of resources available for our needs. If you want to read more about it, read the book Scale. So we need, the only way to solve it is to have constant progress and innovations at a faster and faster pace. And the only way we can be really innovative is to be really creative. And the only ones that are really creative are humans so far. So the better job we do in being creative, we will have a future, or we will die because we don't have resources. And then we'll have Dr. Lewis on Friday, Why Evolution Favors Symmetry. He's a mathematician and philosopher, and it's a really interesting evolution room we'll have. They published a paper recently. And then on Saturday, It's also really exciting. We'll have Dr. Guko P. Dennis from Max Planck Institute, and he is one of the inventor of organic neuromorphic electronics. So it's a really brand new, exciting field in electronics and neuroscience combined. So yeah, it will be. I'm really looking forward to that one. Yeah, if you have any last comments or questions, please go ahead and ask. The hour is almost up. So yeah, please. Yeah, and thank you everyone for being here, for supporting us, for asking questions. It's been great discussions. We are really, I mean, I'm really happy about these discussions and I really love them. The guest speakers always come back and say, this was such a great discussion, such a welcoming group, and with very interesting questions. So I really appreciate that. So thank you to everyone. Thanks for our great team. We are really great. We are doing a really great teamwork. And yeah, I'm happy we have this journey together.
Me too. And given that it seems that no one else has any questions or comments, I guess we can close it, yeah?
Thank you, everyone. So glad that we could do this today.
Yeah.
Thanks, everyone.
Okay, let's close the happy Sunday and let's close the room in 3, 2, 1. Bye, everyone. Thank you.
Thanks.